Alright, it's time for another video. And I have had a request for section 5.3, number 10, and this is using a binomial probability distribution. So, to start this off, the request is also to have a calculator way to do this. And the calculator way to do this, let me show you this. And this is from your TI-83 guide that comes with your calculator. You may have to actually go online to find this. But here is what we're talking about. And there's three key things here that you're going to, three parameters. And here's the three parameters. N is the number of trials. P is the probability of success. And K, this is, I guess, something you got to keep track of. The calculator uses K, which is the number of successes. But in the book uses X. So keep track of that one. It's, instead of K, we've got X. All right. So let's go back to the problem. And I'm going to go through the example for this using the calculator. I will not do the last section. I'm going to leave the conclusion part for you to go through. But here we go. So here's the problem. And let me get my calculator back on stage here. So here we go. A TV show, Lindsay and Tobus, recently had a share of 15, meaning that among the 15 sets in use, 15% were tuned to the show. So that's going to be our probability is 15% or 0.15. Assume that the advertiser wants to verify the 15% share by conducting his own survey. And a pilot survey begins with 25. Okay, this is that K or X that I was talking about. Let's make sure I said that one more time. Let me look back over here. No, excuse me, it is N. Number of trials is N. K or X is the number of successes. We'll get to that in just a moment. Okay, so back over here. And we've got 25 households. So now we've got two of our three parameters at this point. We've got N equals 25. We've got P equal to 0.15. And then finally, we've got the question, find the probability that none of the households are watching it. So here we've got X, which is equal to K, which is equal to 0. Okay, we are now armed to load the calculator. So let's go do that. And here we go. On. And let me clear mine. And then let's go to second distribution, which is vars. And we're gonna, you can type in 0 right here, but if you just want to see where this thing is, binomial PDF, enter. And we enter 25, comma. And then we enter the second parameter, which is 0.15, comma. And then finally, we enter this none right here, which is 0, parentheses, and we hit enter, and 0.1719, da, 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 otherwise, aka 0.017. And now if we scroll down here to see what the actual result is after going through all of this math right here, you'll see that it's 0.017. So we have now done part A with the magic wave of a couple strokes on the calculator. Good old technology. Let us move on. And we're going to part B. And let's find, here's part B. And part B is at least one household is tuned in. Now here we get into probability thinking, which is, it's kind of reverse thinking at times, and that's your easiest solution. Now, if you wanted to, probability greater than equal to 1 is equal to running through each one of these things I did on the calculator from 1 through 25 and adding them all together. Brute force. The other solution is the easy button. If you happen to think about it, all of the other possibilities are 1 minus the probability of x equals 0. That's because if you were to add up all of these things right here, 1 through 25, and then you threw in 0, x equals 0, if you added them all together, you would equal 1, because those are all the possibilities. That's 100% of the possibilities. So if you take 1 and subtract this thing, you're going to end up with the households that are at least looking at, that are greater than or equal to 1. This one we really don't have to spend a whole lot of time on with the calculator, because it's fairly simple. We already know what x equals 0 is. That was from part A. So 1 minus this thing right here is 0.983, which is the answer to part B. Fairly simple. Again, you could have gone through and brute forced it and done this calculator step, and instead of 0, you did 0, and then you did 1, then you did 2, then 3, then 4, etc. up to 25. You wouldn't include this 0, so you'd be doing 1 through 20. So you'd have to execute this step 25 times, and then add the results together. But by the time you did that, you would end up with this right here. Okay. So now let's look at part C. Part C is the last one I'm going to cover. And then you can work your way through part D, because that's a why or why not. And I want you to think about that, but this is the mechanical piece. All right. Find the probability that at most one household is tuned in. So what does at most mean? Well, at most means that, well, maybe no one is tuned in. Well, maybe one person is tuned in. Is two people tuned in? No, can't have that. Because all you're allowed is at most one household. So you're going to use 0 households right here, or 1 household. If this would have said at least 5 households, or at most 5 households, you'd have to be doing point x equals 0, x equals 1, x equals 2, x equals 3, etc. until you got to 5. Okay, let's continue. We're now at the spot where we have to calculate this. And we've already done that one from part A. So I now need to come up with this one. I know part A. I just have to come up with this additional probability. But instead of going through this stuff right here, let's just go over back to the calculator and turn it back on. And here's a secret trick here. Notice I have 25, 15, and I've already covered the 0 case. If I hit second, great, hang on, my southwest trip is around the corner here. Let me get rid of this. How annoying. If I hit second, and then I hit enter, I now have the same exact line that I have up here when I calculated for 0, only I'm able to go back and edit this thing. And I put the number 1 here. It saves me some typing. So I hit the enter button, and I get 0.0758, which is approximately 0.076 plus 0.017. Enter. Whoa, 0.093. And I have finished this problem. And on that note, I am going to shut down this video. One more time. I'm slowly shutting this down. That one. That one. And here's Cam Studio, and I need to stop it, and I am stopping it right